Hello, my amazing students. This is Mrs. A, and I love math. Today we're on lesson 93 in our Saxon Orange book, and we're talking about products of rational expressions, and then we're going to talk about quotients also. So we know that a rational expression is simply a fraction that is made up of polynomial expressions on the top and the bottom, on the numerator and the denominator. Now remember, a polynomial expression could be one term, two terms, or more terms. And rational expressions are fractions made up of polynomials. So when we're multiplying fractions, we know that we multiply the numerators together and we multiply the denominators together. We're always going to want to cancel anything that we can. In this one, it doesn't look like anything will cancel. So we're going to go across. 4 times 3 is 12. X times x is x squared. And then we have an A, lonely A, no partner. And then on the bottom, we have a 5 times y, which is 5y. And there are no factors in the numerator and the denominator, which are the same. Therefore, we have simplified it as much as we possibly can. So that's the basics, but it's going to be much more interesting because we're going to deal with some problems that are a lot more complicated than this one is. All right, this is example 1. And as you can see, I have a binomial divided by a binomial and a binomial divided by a trinomial. I do not want to multiply these together. So what we're going to do instead is factor, 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 cancel, and then multiply together. All right? So we're going to take x squared minus 25, and we're going to say that is x plus 5, x minus 5. Remember, x squared minus 25 is a difference of two squares. It's one of those special factors we talked about, and it will always factor into conjugates, x plus 5, x minus 5. Now let's check it. If I FOIL these back together, I get x squared. My outside term is negative 5x. My inside term is positive 5x. My last term is negative 25. And remember, I get my little FOIL man if I do it right. And so I've checked my factors for the first binomial. Okay, so now we're going to factor the denominator. And the denominator has a greatest common factor. The greatest common factor is x. So we're going to pull an x to the front. X squared divided by x is x. Negative 7x divided by x is negative 7. And we're done with that one. So now we're going to come over here and we're going to factor the numerator on the right, which is also going to have a greatest common factor of x. And x squared divided by x is x, and 3x divided by x is 3. And we're done with that one. And then we're going to do the last one. The last factor is this one down here. And remember, because it's an x squared on the front, it's going to wind up factoring with an x and an x, because that's a minus. It tells me that we have opposite signs. One's going to be positive and one's going to be negative. And I don't know where it's going to go. But then factors of 15 are going to be 15 and 1 or 5 and 3. And we're looking for a difference. Because that's opposite signs, we're looking for a difference. 5 minus 3 is 2. So don't I want the 5 to be negative and the 3 to be positive? So minus 5 plus 3, x squared minus 5x plus 3x is negative 2x minus 15, and it works. Okay, so that was how we factored initially. Okay, let me see if I can get the glare off of there. So that's how we factored initially. So now you can see that a lot of this is going to cancel out. Let's watch. So I'm going to get a different color for the canceling. All right, so we have an x minus 5 and an x minus 5. We have a x plus 3 and an x plus 3. And we have an x and an x. And I think that's all I can do. So the final answer, the only thing left in the numerator is x plus 5. And the only thing left in the denominator is x minus 7. So x plus 5 over x minus 7 is the final answer. Now, factor, 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 factor. Cancel, 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 cancel. And then multiply. Here's our second example. We have a trinomial divided by a trinomial and a trinomial divided by a trinomial. So again, factor, 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 cancel anything we can, and then finally multiply together. So let's look at this first one. We have an x squared, so it's going to be one of those easier ones that just starts with an x and an x. This one is a minus, therefore we're going to have one plus and one minus, and this middle term will be a difference. So we're looking for a difference. When we're looking at 6, 6 could be 6, 1, or 2 times 3. We're looking for a difference of 1, so we want to choose the 2 and the 3. So 3, 2, we want it to be a positive 1, so make it a positive 3 and a minus 2. Okay, so when we FOIL it in our head, we see that we do get that when we FOIL it back together. Okay, so now in the denominator, we have an x squared, so it's one of the easier ones, and negative, so opposite signs. That means this is going to be a difference. 21, 7, and 3, difference is 4. So we're going to use a 7, a 3. We want the difference to be negative, so we're going to make the larger of the two numbers negative, the other one positive. We're going to FOIL to check and make sure that we do indeed get what we're supposed to, and we do. We're going to come over here, put a times sign, and do our numerator over here. We have an x and an x. A 7 only factors 7 times 1. Positive means same sign. Since this is negative, they're both negative signs. Same sign, both negative. And so we have 7 and 1. Negative 7 times a negative 1 gives me a positive 7. A negative 7 plus a negative 1 gives me a negative 8. And so I get my intended product up here. And lastly, we have the denominator down here. We have an x, an x. Again, we have a 2, which is 2 times 1. A negative, which means opposite signs, and that this is a subtraction. And we want it to be negative, so we'll make negative 2, positive 1. And we have factored everything pretty quickly. Okay, so now we're going to get a different marker and cancel everything that will cancel. So let me get something that'll stand out here, like red maybe, and we'll play the canceling game. All right, we have an x plus 3 and an x plus 3. We have an x minus 2 and an x minus 2. We have an x minus 7 and an x minus 7. Almost everything canceled. The only thing that didn't cancel is an x minus 1 and an x plus 1. X minus 1 over x plus 1 is our answer. You see how easy it is if you will carefully factor, 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 factor. Right, so now we're working on division of rational expressions. And remember, rational expressions are just fractions that are made up of polynomials. So we're going to start with the simplest type of a fraction, and we're going to divide. Now remember, when we divide a fraction by another fraction, we flip and multiply, don't we? But let's see why we flip and multiply. Let's multiply by 1 in the form of the reciprocal of the denominator, because don't we want to get rid of that denominator? So we're going to multiply by d over c, but if we multiply the bottom by d over c, don't we need to multiply the top by d over c also? Now, when I cancel, the denominator now goes to 1, and we don't even need to write it, and guess what my new fraction is? A over b times d over c is the same thing as a over b divided by c over d. So can you see how I took the reciprocal of c over d and multiplied by it? And so that's the rule. When we're dividing by a fraction, we're multiplying by the reciprocal of the divisor. So here's our first division problem. And again, it looks a lot like our multiplication problems, but we have a division sign here. So I suggest that you factor, just like you did before, but we're going to flip and multiply before we start to cancel. So this one is going to be an x minus 2. This one is going to be an x and an x, 8, but a difference. Okay, so 8 could be 4 times 2, and 4 minus 2 is 2. So 4, 2, positive, minus will work. Now, I'm going to go ahead and multiply. And since I'm multiplying, I'm going to take these factors and bring them down here. So I'm saving a writing step. So x squared plus 5x will factor as x times x plus 5. Notice it was division here, so I put that down in the denominator because I am flipping as I factor. This one has got an x, and it's going to go in the numerator because I'm flipping. 12 could be 3 times 4, and 3 plus 4 is 7. So plus 3 plus 4. And look how I have it written now as a multiplication problem, and I have already flipped this over and changed to multiplication. So now I'm going to do exactly what I did in the last problems with multiplication. So I have an x minus 2, an x minus 2, an x plus 4, an x plus 4. I should have used a different marker, and I forgot to do that. But you can see that we have an x plus 3 on the numerator and an x plus 5 on the denominator. So that is our answer. Let me see if you can get to see the whole thing in one fell swoop. Okay, and then I'll move in closer so you can see that answer. Okay, so here is our last division problem, and then we'll go on to our practices. So here we have a trinomial divided by a trinomial divided by a trinomial, and a division sign in between. So factor x. 6 could be 3 times 2, and the difference, remember that says a difference. So we're going to say minus 3 plus 2 because we want the middle to be negative. Then we're going to put this one here, and we're going to have an x and an x. And 10 is 5 times 2. We're looking at a difference. 5 minus 2 is 3. But don't we want the 5 to be the negative one? so that we end up with a -3. Now, again, I'm going to switch to multiplication. So this factor is going to go down here. And x, so I'm flipping as I factor. X squared, positive, positive. So it's going to be same sign, both positive. 4 could be 4 times 1, which would add to 5. 4 times 1, which will add to 5. Now, this one is going to factor into the numerator because I'm flipping. X, 4 times 5, difference, -5 plus 4 gives me a -1 in the middle, but a -20 on the end. So those are our factors here. Let me get a different color and come back and cancel. Okay, so we have an x minus 3 and no other x minus 3's. We have an x plus 2 and an x plus 2. An x minus 5 and an x minus 5. An x plus 4 and an x plus 4. So we are left with an x minus 3 here and an x plus 1 in the denominator. And we are ready for practice problems. Okay, here is your first practice problem. So copy it down very carefully and then pause your video and go try to do it by yourself. And don't start the video until you've given it your best shot, because you want to learn how to do these by yourself, not just with me. Okay, copy it down and pause it. All right, hopefully you have worked the problem. So now we're going to factor, but it's a division. So we're going to flip as we factor. This one will go right here, and it will be an x and an x. Minus sign tells us we're talking about opposite signs and a difference. So we're going to have a minus and a plus. We have a 6, could be 6 times 1, but their difference is not x. So 3 times 2, that difference is 1, isn't it? So 3, 2. Now when I FOIL that, I should get that, shouldn't I? All right, so then this one, x. What are the factors of 16? 16, 1, 8, 2, 4, 4. We're looking for a difference, which means this will be a subtraction. We're looking for 8 and 2, aren't we? Okay, so we're going to use 8, 2, minus, plus, and that will give us this trinomial. So now we're going to flip. So we're going to change this to multiplication. When I factor this one, I'm going to factor it down below so that I'm flipping as I do it. X, and no, this is a binomial, so it's going to be an x and an x minus 3. And I really don't need, I could have just pulled out a common factor there. So I'm factoring it, but I'm throwing it downstairs so that it's flipping. And then this one is going to go upstairs because I'm flipping. Now think about 40. 40 could be 40 times 1, 2 times 20. We're looking for a difference of 3. 4 times 10, 5 times 8. It's going to be 5 and 8, isn't it? All right, so 5, 8. We're looking for a minus 3. So minus, plus. Now when I FOIL it, I get x squared. 5x minus 8x is negative 3x, and a minus 40. Okay, so look at all the factors before we start to cancel. All right. So x minus 3, x minus 3, x plus 2, x plus 2. X plus 5 does not have a partner. X minus 8, x minus 8. So we're left with x plus 5 on the top over x. X plus 5 over x. Hopefully, you did that all by yourself. All right, we are on the last problem, so copy it down carefully and try to do it on your own before I do it for you. So pause your video. Okay, so hopefully you paused your video and did your work. We're going to look in its multiplication, so we're going to factor just as we see them. X, 36. Now let's think about 36 times 1, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Those are the factors of 36. Now let's think about this. We've got 12 and we've got a sum. So won't we use 6 and 6? Because 6 and 6 will give us a 12, but multiply to 36. So 6, 6, plus, plus. Now FOIL it in your head and see if you don't get what you're supposed to there. Do you see how I do this factoring? I start with the number times 1, and I bump it up to 2, and write the factor. 3, and the factor. 4, and the factor. 5 does not go into 36, so I don't try that one. 6 times 6. Try to be methodical and systematic. Okay, so now we're going to do this denominator. X squared is x times x. We have a 42. 42 and 1. 2 and 21. 3 goes into 42. And that's going to go, I think, 14 times. Let me see. 42, 3, 1, and 12. 14. 14 times 3. And then 4 doesn't go into 42. 6 and 7 go into 42. So that's the one we're going to use, is 6 and 7, because we're trying to get to a 13. 6, 7, plus, plus. Times, so nothing has to change, nothing has to be flipped. So we factored the first one, and now we're ready to factor the second one. Okay, so we're going to have an x. 21 is 3 times 7. 3, 7. There's a difference. We want the positive, so we're going to put a positive 7 and a minus 3. And lastly, we're going to factor this one. X. We've got 24. 1, 2, 12, 3, 8, 4, 6. We're talking about a difference, so aren't we going to choose 4 and 6? So 4, 6, positive, minus. All right, look at everything there. Now we're ready to do the canceling, and we will be done with our last practice problem. Okay, so x plus 6, x plus 6, x plus 6, x plus 6. X minus 3 has no partner. X plus 7, x plus 7. The answer is x minus 3 over x minus 4. And we are done with that lesson. Sorry about the little bright spots. We're working on a different lighting situation, but it's not here yet. So, hopefully, that has taken a lot of mystery out of rational expressions for you. I hope that you will enjoy your assignment as much as I enjoy rational expressions. I love to multiply and divide because at least your book is making them cancel out very nicely, and so it's a lot of fun. And this is Mrs. A, and may God bless your day.